The title of this video is Significant Figures, How to Make a Measurement. In this video we will learn how to make a measurement. You would think by high school students would be able to make a correct measurement, but sadly many can't, so we're going to go through this fairly simple video. All measurements need a measuring tool and something to measure. It's important that the correct measuring tool is used for what you are trying to measure. Let me give you some examples. Measuring tools may be a meter stick, a graduated cylinder, a balance, or a clock. Let me give you an example of an inappropriate measuring tool. It would not be appropriate to use a clock to measure a 100-meter dash. Oh, I'm sorry. It would not be appropriate to use a classroom clock to measure a 100-meter dash. Or let me even get more extreme. You wouldn't use a calendar to measure a 100-meter dash. You may use a calendar for some people to measure the speed of a 100-meter dash, but not most people. A calendar may be used to measure the time it takes to have an ocean voyage around the world, but it wouldn't be used for a short amount of time, like a short run. Let me give you some other examples. You wouldn't want to use a meter stick to measure the distance from to the moon, for example. You wouldn't want to use a meter stick to measure the width of a piece of hair. You wouldn't want to use a graduated cylinder to measure the volume of a swimming pool. You also wouldn't want to use, let's say, a cup measuring tool to measure a very tiny drop of water. So it's important that we use the correct measuring tool for what we're trying to measure. When using a measuring tool, you should always read the number and the tick marks correctly, and then you must take an additional guess or an approximation. It's very difficult to get students to take the approximation, to take the guess. Most don't want to do it, but it's an important part of taking any measurement. Let me give you an example. Let's say that we want to use this ruler to measure the length of the paperclip. The paperclip is between 2 and 3 centimeters. This is not a very accurate ruler. It only has one mark between the centimeters, the 0.5 mark. Let's say that the end of this paperclip is right at the 0.5 mark. So how long is the paperclip? Well, most people would put 2.5 centimeters. What's wrong with that? Well, there's no guess taken. The 0.5 is clearly a tick mark on the ruler. The 2 is on the ruler. You have to take a guess. So to use this ruler appropriately, and if the end of the paperclip is right on the 0.5, we must add a 0. Why? Because you have to take a guess. You always have to take a guess. Here's another example of how to make a correct measurement. I would like to know how long the red block is, and I have 3 different measuring tools, each one a little better than the one before it. Let's start with figure 1. Figure 1 is a meter stick with no tick marks. A tick mark being the little lines on the measuring tool. It can still be used, but not to any high degree of certainty. Let me give you an example. How long is the red block? Well, it appears to me to be about 0.3 meters. In this case, I don't have any tick marks, so my first number is actually the guess. It looks to me to be about 0.3 meters. And that's about as good as we can get using this measuring tool. This number, this measurement, actually has one significant figure. One number that has meaning. We did actually measure the block using that measuring tool. Now, I want to go to figure 2. Figure 2 has tick marks. It has 10 equally spaced regions. It's called a decimeter, but to make things simpler, we're going to stay with the meter in all of 3 of these measurements. Now how long is the red block? Well, it's not quite 0.3 meters as we thought before. It's, let's say, 0.2 meters. Now 0.2 is actually right here, and you can see it's quite a bit longer than 0.2. And we haven't taken a guess yet. My guess is going to be an 8. You may disagree with that. That's okay, because there's some uncertainty in the last number of a measurement. It is a guess, an educated guess. Now, how many significant figures does this measurement have? It has two numbers that have meaning, or two significant figures. Now notice the red block didn't get any longer or shorter, but our measurement device determines how accurately we're measuring the length of the red block. Now, if we want a better measurement, we need a better measuring tool. Figure 3 is the best measuring tool on this page. Now, how long is the red block? Well, we're going to zoom in here a little bit to get a better look, but the best I can see, it appears to be 0.28. And if we get in here and look real close, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. Well, I count 8 little tick marks. So the 8's not a guess because there's 8 little tick marks there. So what is my guess going to be? Well, it appears to be exactly on the 8, so my guess may be a 0. It's a guess, you may disagree with it, but that's the best I can do with this measuring tool. How many significant figures do we have here? How many numbers can we count on? Well, there are 3 significant figures. Now, do I know exactly how long the red block is? No, of course not. That would be impossible to determine. I could have yet another measuring tool that has 10 more lines, and another measuring tool that has 10 more lines than that, etc., etc. I could get a better and better measuring tool down to the billionth or the trillionth of a meter, but I still wouldn't know exactly how long the red block is. So if you want a better measurement, you need a better tool, and you need to use the tool correctly. To use the tool correctly, you put down all the numbers that come from the measuring tool that are on the measuring tool, plus you take one guess always. Now I'd like to talk about making a measurement using a graduated cylinder. A couple terms, or at least one term. The curved line on the screen, well, first of all, this is a graduated cylinder and there's a liquid in it. This curved line is called a meniscus, and we always use the bottom of the meniscus to make a measurement in a graduated cylinder. It's very important that your eye is level with the bottom of the meniscus when you're making the measurement. That's what this picture is showing you. Also, it's important that you know what the little lines mean. Obviously, that line's 30 milliliters, and this line is 40 milliliters. If you were to count, you would count 10 equally spaced segments. So each line is 1/10 of a milliliter. Or I'm sorry, each line is 1 milliliter, because the difference between 30 and 40 is 10. So how much fluid is in this graduated cylinder? Well, as you can see here, it's 32 milliliters. But remember from our video before, we have to make a guess. If it appears that the meniscus is sitting right on the 32 mark, our guess would be 0. Why take the guess? Because in every measurement you take a guess. Now if there were just a tiny bit more fluid in this graduated cylinder, it might be 32.1. Tiny less might be 31.9. That last number is significant. You need to record it. Now let's talk about the size of the graduated cylinder. How do you know what size graduated cylinder to use? Well, this is a 10 milliliter graduated cylinder, this is a 50 milliliter graduated cylinder, and this is a 100 milliliter graduated cylinder. When would you use each one of these? Well, If I was going to measure 80 milliliters, I'd use the 100. If I was going to use 20 milliliters, I'd use the 50. If I was going to measure 2 milliliters, I'd use the 10. Which one would you use to measure 7 milliliters? Well, this only holds 5. You could fill it up to 5 and then fill it up to 2. Or you possibly could use this one to use 7 milliliters also. You should always use a size appropriate graduated cylinder for whatever you're measuring. It would not be appropriate to use a beaker to measure 5 milliliters. Beakers are way too big and they don't have very many tick marks on them. They're not calibrated well. Now, to highlight that point, let's take measurements of fluids in each of these measuring devices. This is a beaker. Beakers are only used to make approximate measurements in volume. What would you put for this particular volume of fluid? Well, it's between 40 and 60, and that little line would then mean 50. Well, I'm going to say 48 milliliters. Now, what's the guess there? The guess would be the 8. There is no 8 mark on there. It's just a little less than 50 and quite a bit more than 40. How many significant figures? There are 2 significant figures. Now, that would only be an approximate. That's a very poor way to measure 48 milliliters. It would be much better to measure it in a graduated cylinder that held 50 milliliters. You could get more significant figures that way. Now, let's measure this fluid in a graduated cylinder, probably a 50 milliliter graduated cylinder. You're going to use this device when you want a more accurate measurement. What would we record for the volume of this fluid in the graduated cylinder? Well, it's between 35 and 40. How many little sections do we have here? We have 1, 2, 3, 4, 5 sections. Between 35 and 40, each one must be a milliliter mark. Well, it's a little above 36. 36 milliliters. But there's a 36 line right here. And I haven't taken my guess yet, so I need to do that. 36 point, what do you think? Where do you think the bottom of the meniscus would be? I'm going to put 4. You may disagree. Again, it is an educated guess. There is some uncertainty in that last number. But it is nevertheless important because we are using the measuring tool to get it. How many significant figures? There are 3 significant figures in this measurement. It would be an accurate way of measuring the volume of this blue fluid. Now, a burette. A burette is the most accurate way, or one of the most accurate ways of measuring fluids in the chemistry laboratory. How much blue fluid is in this burette? Actually, this is a little tricky because we don't really want to know how much is in the burette. We want to know how much has left the burette. If you read here, how much fluid has been emptied from the burette? Assuming it starts at 0 and we're working our way down. So fluid is coming out the bottom. How much fluid is left? We started with, let's say, 50 milliliters and we've emptied it to this point. Well, I want to know where this little mark is. There's 20, there's 21. This would be 20.5. This must be 20.4. This must be 20.3. So 20.3. Now, is the 0.3 represented by a line? Well, 0.1, 0.2, 0.3. Yes, it is. So it's not a guess. I need to take my guess. It looks like it could be 8 or 9. I'm going to go with 9 milliliters. You can see that's a very accurate measurement because it has 4 significant figures. The more significant figures a number has, the more accurate it is. What number aren't we absolutely certain with? Well, that would be the 9. Finally, I'd like to talk about plus or minus notation. There should be a way that scientists can represent that their last measurement, their last number in a measurement, has uncertainty, and they do using what's called plus or minus notation. You see here at 3a, scientists say that there's a 90% chance that the guessed number is a measurement that is accurate to plus or minus 1. Now what does that mean with a real measurement? Let's go back to the paperclip that we started with. A scientist would then write after the paperclip plus or minus 0.01. What does that mean? Well, that tells a person that the measurement is somewhere between 2.49 and 2.51. You see, if I subtract a 0.01, I get this number, and if I add a 0.01 to the original measurement, I get this number. We don't know exactly how long the paperclip is. We just know it's somewhere between 2.49 and 2.51. In all measurements, it's assumed that the plus or minus notation is one higher or one lower for the last number in the measurement. Let's use it a couple more times to get used to it. Let's go back now to the red bar. So what would we put for the first length? Well, if it only has one number, the plus or minus notation would be, in this case, 0.1. In this case, we know it's somewhere between 0.2 and 0.4. Yeah, that's a very big range, and that's because it's a bad measurement. It's a bad measuring tool. Let's go down to the second one. That last number could be one higher or one lower. That means it would be plus or minus, I always do that, 0.01. So that last number could be one higher or one lower. The 8 could be one higher or one lower. Somewhere between 0.27 and 0.29. Here, the last number is a 0. So we'll do plus or minus. Didn't do it that time. Oh, good. Didn't get the plus right, though. Plus or minus. That last number could be one higher, one lower, so it's 0.001. It still has three significant figures. So that number is somewhere between 0.279 and 0.281. That's the way we use plus or minus notation to represent the measurement, the uncertainty in that last number. Could be one higher, could be one lower. That's all.